So 35 in our textbook is another rotational problem. And let me read it out loud to you guys. And then we'll go from there. It says, what net torque is required to give a uniform 20 kilogram solid ball with a radius of 0.2 meters and angular acceleration of 20 radians per second squared? Okay? So we have a ball, a sphere, okay? And so we'll just pretend that this is the sphere. Whoops, I got two of them now. I only need one. Whoops. Delete. All right, and so what they tell us in the book is this thing, what does it take to get this thing moving? All right, how much torque do we need to apply to a ball? Does it give us the radius? Yeah, a radius of 0.2 meters. So we have the radius of this ball. The radius is equal to 0.2 meters. And the mass of the ball is 20 kilograms. Okay? All right? And then we want it to have an angular acceleration of 20 radians per second squared. Okay? So this is going to be 20 radians per second squared, the angular acceleration. All right. So the relationship that we need to consider is the torque. So the torque, remember, is the moment of inertia times the angular acceleration. You may not have memorized that yet, but that's what it is. And we're trying to figure out the torque, so then the moment of inertia is based on the sphere. Now remember on the PowerPoint slide I went over with you guys in class, there were like 12 or 10, I don't know, there was a whole bunch of scenarios. What is the moment of inertia of a sphere? Does anybody remember that off the top of their head? And if you want, let's look in our textbook, because you probably don't. There were a whole lot of them. Okay? And in your textbook on page, let me find the page. Or it might not have been, it might have just been in the, it might have just been in the notes. Oh no, on page 284. Page 284, we get a bunch of formulas for calculating the moment of inertia. So which one do we use for a sphere, a solid sphere? Anybody know? G. Can you say that out loud?
I equals 2/5 mr squared.
Do we know the mass? Do we know the radius? So this moment of inertia gets replaced with 2/5 times the mass times r squared. And then we tack on the angular acceleration. So we need to figure out the torque that's needed. In other words, we're going to apply a torque force to get that thing rolling. And we need to figure out what that is. All right. So that's equal to this stuff, or 2/5 times the mass of the object, which is 20 kilograms, right, times the radius of the object squared, which is 0.2 meters squared, times the angular acceleration, which is 20 radians per second squared. Is that right? Well, let's multiply that all out and see what we end up with. So I'm going to, let's multiply that all out, slide this over a little bit, whoops. And see what we get. So I've got 2 divided by 5 times 20 times 0.2, but that's squared, times 20. Oh, wait. Was it 20 or was it 2? Let me read it. I think I wrote it down on the board wrong. I think it was 2.0, the angular acceleration. I think I wrote it down wrong because my notes say 2, and I think I wrote down 20. Mr. Adams needs to get some glasses. That's interesting. No, that's the right answer. So my notes, for some reason, when I did my notes, it had the angular acceleration at 20 radians per second squared. However, if I do that, I get 6.4, which is the correct answer. It should be 6.4. So if you look in the back of the book, it says like 0.64 for whatever reason. Well, let's double check the back of the book. So there might be an error in the notes, or in the back of the book. Let's see. What problem was that? 35. Yeah, they have 0.64, but that's based on 2 radians per second squared. So sometimes the textbook, and I ran into this before, and I hope I've skipped those problems, but basically they used the wrong angular acceleration when they calculated the answer in the back of the book. So the correct answer should be this 6.4. So it's 6.4. And then if you combine the kilogram, meter squared, radian squared, all that stuff, you'll end up with meter newtons. So that's how much torque you should apply.